Hi everybody, in this video we will do the homework for section 4 of chapter 4, combinations and permutations. And as you can see, I have my homework setup going on here. I have Hawks over here, I have my calculator, and I have OneNote. Once again, in Hawks we have Learn, where you can which is basically kind of like listening to my lectures, probably just not as boring. We have Practice, where you can practice, and then Certify is where you get it done. Notice that in Certify, we have 10 problems, you have 3 lives, so you need to get 7 of the 10 problems correct to certify. Having said that, you might also want to go ahead and do the other 3, because if those 3 may be the ones that are the 3 you miss, maybe the 3 on the exam, so you might want to go over them anyways. And always, if you certify before the due date, you'll get 100 on your homework. If you certify sometime after the due date, you will get something other than 100, obviously something less. Okay, as usual, I'm going to go into practice. So let's go ahead and start with practice. And here is our first problem. A doctor visits her patients during morning rounds. In how many ways can the doctor visit 7 patients during morning rounds? Hopefully you've seen this either in class or in one of my previous videos. So the answer to this this is a permutation problem. Order matters. So this is going to be 7p7. Okay? Which would be 7 factorial divided by 7 minus 7 factorial, which is 0, or just 7 factorial. So you could either find the solution using this, or you could find the solution using our piece. We're going to do it the former, using our piece. So we can come to our calculator, we can type in 7, or put in a 7, go to Math, over the probability, go down to NPR, hit Enter, put in our second 7, and then hit Enter again, and that is our answer, 5,040. And there we go. Moving on, our next one is a musical lineup problem. A conductor will select 5 songs from a list of 10 to compose an event's musical entertainment lineup. How many different lineups are possible? Now, hopefully you guys can read this and discern that the order of the musical arrangements actually does matter. So this is a permutation problem. This is going to be how many permutations of 5 can we get from a collection of 10? 10p5. Now there's 2 things you can do. One is you can go back in and do what we've done before, or we can go ahead and use your history. Notice we actually have the NPR thing up here. So we can highlight that and we can hit Enter. Okay, we can come all the way back here and replace 7 with the 10. However, we have to be a little careful because 10 is a 2-digit number. We only have 1 digit here, and the calculator tends to overwrite. So we can put a 1. Now we had to insert the 0. Here's insert right there. So I can do second, insert, put in my 0, and then I can come over here and put in my 5. And there we go. That will give me my answer, 30,240. Okay, next. How many ways can Patricia choose 4 toppings from a menu of 8 toppings if each topping can be only chosen once? Now, we're putting stuff on a pizza. Hopefully you can you can look at this and discern discern for yourself using your critical thinking skills that order doesn't matter. As a consequence, the answer to this is going to be 8C4. Sounds like an explosive. Or sometimes we will read this as 8 take 4. We can do that using our calculator. Go into Math. No, that's wrong. First thing, type in 8. Then go into Math. Go into Probability. Go down to C. Hit Enter. Put in 4. Hit Enter again. And that would be your answer. It would be 70. Okay, now we need to evaluate the expression 9 factorial. That should be relatively straightforward. You can actually do that by doing 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 if you want. Or you can type in 9, Math, over the probability, go down to the exclamation point, hit Enter, hit Enter again, and it is that ungodly number right there, 362,880. Okay, next is 9 factorial divided by 3 factorial. Now this is what we should be able to do. I should be able to highlight the 9, hit the 9 factorial, hit enter. It's down here. Hit divide, and then put in 3 factorial, which would be 3 math probability 4, 9 factorial divided by 3 factorial. That is going to be equal to 60,480. That should also be equal to 9 times 8 times 7 times 6 times 5 times 4. And it is. So there's a couple ways to do these. How you choose to do them is entirely up to you. Just have to make sure you get the right answer. Okay, now here we have 13 factorial divided by the quantity 3 times 3 minus 13 factorial. So we could compute this directly, or we could recognize that, hey man, you know what that is? That is 13C3. So we could go in, we could type in 13, go into math over to probability, go down to NCR, hit enter, put in 3, and that will give us 286. Or we can compute directly, we compute exactly what's there, and when I compute these things, I like to compute the numerator, then compute the denominator, and then divide the two. So the numerator is 13 factorial. Okay, then we get that ungodly number. And then the denominator is 3 factorial times parenthesis 13 minus 3. I suppose we could have just done the math in our head. Factorial. And then we can divide the two. Highlight the numerator, enter, divided by, highlight the denominator, enter, enter, 286. So two different approaches, exact same number, chances are it's right. Okay, and we have 4 problems left. Here we want to do 7P5. Okay, cool. 7 math P5 2,520. All right, next we have 13C7. So we can go in and do all that again, or notice in our history we have a 13C3. So we can actually take this, hit enter, brings it down, and all we got to do now is just change the 3 to a 7. So this is where you can actually have your calculator save you some keystrokes. And that gives us 1716. All right, 2 more problems left. There are 11 people in an office with 4 different phone lines. If all the lines begin to ring at once, how many groups of 4 can answer these lines? This is another situation where order does not matter. Therefore, this is going to be 11C4. Once again, we can go ahead and we could go into math and do all this, or what we can do is highlight, use our history, highlight this, bring it down, change the 13 to an 11, change the 7 to a 4. Hit enter. That should be our answer, 330. And then for our last problem, we have a newly elected president needs to decide the remaining 3 spots available in the cabinet he or she is appointing. There are 12 eligible candidates for these positions where rank matters. Okay, the phrase where rank matters tells you that order matters, which means we are dealing with a P problem. Okay, how many different ways can we do this? 12P3. Since I have nothing in my history right here, I'm going to go ahead and do this the old-fashioned way. So we have 12 math over the probability, going down to P, hit enter, type in 3, and that is your answer, 1320. And there you go. And that is how you do your homework for this particular section. It is very, very calculator dependent. This will give you an opportunity to get used to your TI, whether it's the TI-84 Plus or the TI-84 CE, which operates a little bit differently. As always, if you have any questions, please feel free to contact me. This is Bob Boyle, signing off.